February 20th, 1943, north of Kasserine Pass, Tunisia. General Alfred Gauss, watching the American advance through the dust, commented wryly, "They are still learning." This was what was said in the high command of the Africa Corps, that the Americans were slow, inexperienced, and their tanks inferior. What he did not know was that at that very moment, the enemy was executing a maneuver impossible according to the manuals of German doctrine. 5 Sherman tanks separated by hills and miles advanced as one. No flags, no visual signals, no delay. This surgical precision was not the result of discipline or luck. It was the effect of something the Germans neither saw nor understood, a military radio network operating on frequency modulation, which connected all American tanks in real time, a technology that not only transformed the battlefield, but silenced the arrogance of those who thought they had seen it all. This documentary reveals the untold story of America's invisible weapon, how industry, engineering, and the logic of mass production created not just tanks, but nodes of a network that the enemy never knew how to decipher, and that he won even before shooting, because on the modern battlefield, talking is to survive. But before we dive into the data, there's one statistic that defines this story better than any theory. In 1944, at the height of armored warfare, German Panther tanks, with superior armament, thick armor, and longer range, faced off against American Sherman medium tanks, which were considered technically inferior in almost every visible respect. The result? For every Sherman lost, 7 Panthers were destroyed. 7. The mathematics of destruction made no sense to the German high command. The doctrine said that they would win with quality, but the battlefield revealed another logic, an invisible logic. If you value facts like this, real, uncomfortable but decisive, and believe in the importance of telling what the books left aside, leave your like and subscribe. This helps the channel to continue revealing what the enemy has never understood. At dawn on February 20th, 1943, at the Kasserine Pass, red desert dust rose like curtains before the eyes of German forces. For the Africa Corps, that mountainous stretch of Tunisia was just another maneuvering stage, and the American tanks, still seen as inexperienced, would be easily driven back. But something strange happened that morning. The platoon of the 10th Panzer Division spotted 5 Sherman tanks moving in scattered formation, separated by hills, with no line of sight to each other, charging forward as if they knew exactly where each other was. There were no flares, no corridors with messages, no flag, no visible command gestures, just tanks that moved with choreographed precision, as if they were linked by a common consciousness. The German commanders, equipped with amplitude-modulating FUG5 radios, attempted to coordinate a response, but the receivers squeaked with interference. The dust, the motors, the magnetic fields, everything conspired against the clarity of the orders. Most of the Wehrmacht's tanks did not even have the ability to transmit. They could hear, at most, but not answer. At this moment, Lieutenant Friedrich Jäger and his Panzer IV realized that the Americans were not only advancing, they were reacting. One Sherman covered the other's flank before the German attack even began. An American artillery piece fired in support, minutes after a tank pointed its turret in a certain direction. The feeling was that the American tanks were seeing through the hills. "This is not training. That's something else," Jäger wrote days later, in an intercepted report. The high command, however, ignored it. They said it was a coincidence, that the Americans had learned from the British, that they were just imitating well-trained maneuvers. But in the field, the sergeants knew this was not normal. Throughout the Battle of Kasserine, American units, even fragmented, maintained a coordination inexplicable by the standards of German doctrine. Platoons separated by miles communicated threats, adjusted positions, called in reinforcements, and retreated in an orderly fashion, without ever seeming lost. Meanwhile, the Germans relied on a rigid chain of command, where the destruction of a single tank leader was enough to disorganize the entire group. Germany's armored doctrine, once celebrated for the efficiency of the Blitzkrieg, now stumbled over its own pride. And the irony was cruel. It was the Germans, under the leadership of Heinz Guderian, who in the 1930s had insisted on the use of radios in tanks. But in 1943, production did not follow the doctrine. The result? Only 1 to 2 tanks per platoon with transmitting capability. The others fought in silence. As confusion spread in the desert, one statistic hung like an uncomfortable shadow. The United States that year produced about 11,400 SCR-508 radios for tanks, while Germany, over the entire course of the war, would produce about 6,000 FUG5 transceiver radios. In other words, American production in a single year was almost double that of total German production. If this difference surprises you, comment below. Shocking data. Because that number alone explains why the Germans were losing the war, without understanding why. As the fighting continued, the Germans resorted to old tactics. They aimed at tanks with multiple antennas, certain that they were the command vehicles. But they made mistakes. In the Shermans, everyone had a radio. Each one could coordinate, each one could lead. German doctrine, based on visual hierarchy, had no answer for an army where leadership was distributed over radio waves. By the end of the day, the American tanks had retreated to new positions, but they had left a trauma on the German front line. It wasn't brute force that baffled them. It was the invisible, what the eyes did not see, but which decided the battle. In the 10th Panzer Division's after-action report, the intelligence analyst summed it up cautiously. American forces have demonstrated unusual tactical discipline. Their quick response seems to be the result of strict training and efficient signaling. No mention of radios. No suspicion that each Sherman was connected to a larger system. The real American trump card remained invisible, exactly as planned. But the Germans were just beginning to understand what they had faced, because what they saw in the desert was just the beginning. In the next phase of the war, this invisible network would begin to expand. What the Germans called tactical discipline would soon prove to be something far more dangerous. Engineering applied on a continental scale, and when they realized, it was too late. The scene in Kasserine was not an accident, nor a flash of American luck. It was the result of a decision made 2 years earlier, quietly, inside a conference room at the War Department in Washington. In July 1941, the United States Army approved the standardization of a new communication system for its armored vehicles, the SCR-508, SCR-528, and SCR-538 radio arrays. It was the beginning of a technical revolution that Germany would not see, and when it did, it would not be able to follow. Behind this transformation were two little-known names outside military circles, Daniel E. Noble and Henryk Magnuski. Noble, chief engineer of the Signal Corps, was the one who had the strategic vision. Magnuski, a naturalized Pole, was the brains behind the practical solutions. Both worked for Galvin Manufacturing Corporation, a small Chicago company that years later would become Motorola. Their proposal was simple and bold: to replace the fragile and noisy amplitude modulation, AM, radios, used until then, with systems based on frequency modulation, FM. For many military personnel at the time, this seemed unnecessary. AM radios worked, but they malfunctioned, especially in the chaos of a battlefield where engines, explosions, electrical sparks, and rough terrain created a hostile environment for any unfiltered signal. Frequency modulation promised something different: stability, clarity, immunity to interference. Where an AM radio sizzled, an FM radio transmitted a clear voice. Where an AM system failed in front of a simple spark plug, the FM cut through the noise like a razor. The SCR-508 was the heart of this system. Its BC6004 transmitter operated at 25 watts of power, 2.5 times stronger than the German FUG5. It used crystal-controlled oscillators, which allowed the frequency to be kept stable even under thermal variations and violent vibrations. It could operate on up to 10 pre-configured channels, allowing quick switching between platoon, company, and battalion networks. Next to it, the BC6003 receiver monitored simultaneous transmissions, something unthinkable on German radios. This meant that an American commander could listen to his chain of command and his platoon at the same time, without manually switching between frequencies. The engineering behind it was more than robust. It was precise. Each SCR-508 assembly included more than 2,700 components, with 474 capacitors and 385 resistors, all individually tested. The power supply was filtered, stable, adjustable to 12 or 24 volts, and immune to electrical interference from the vehicle itself. For the U.S. Army, this standardization was not just a technical issue, it was a doctrinal choice. Every Sherman tank that rolled off the assembly line in Detroit was already equipped with the radio. There was no exception. It was not a luxury of command vehicles. It was the standard. The radio was no longer an accessory. It was part of the gun. This total integration contrasted with the German reality. where radio was a scarce resource, allocated only to key vehicles. Ordinary tanks, for the most part, carried only receivers. In many cases, not even that. Coordination for the Wehrmacht still depended on visual signals, flags, and pre-planning. Real-time tactical improvisation was limited by the ability to communicate. In the United States, the relationship between the Army and industry was not only functional, it was symbiotic. Galvan Manufacturing repositioned its entire production line, which previously made car radios, to meet military demand. The factories worked in 3 shifts. Assembly lines were adapted with almost surgical rigor to ensure repeatability. No part could deviate from its specifications. The Army provided the standards. Motorola delivered. It was the fusion of military planning with the American culture of mass production, and this generated scale. In 1942, 3,800 units of the SCR-508 were produced. By 1943, that number had risen to 11,400. In 1944, to more than 24,000. By the end of the war, more than 50,000 radios had been installed in tanks, nearly one for every Sherman produced. No other nation has achieved this rate of equipping. Germany, suffocated by material shortages, factory bombings, and a culture of artisanal engineering, has never been able to produce radios on a similar scale. The American choice to sacrifice complexity for standardization proved lethal. For American engineers, the challenge wasn't just technical, it was logistical. They needed a radio that could be installed quickly, operated by soldiers with limited training, resistant to knocks, heat, dust, and noise, and yet reliable as a rifle. The SCR-508 fulfilled all these requirements. Radio became the backbone of American mobile warfare doctrine. It allowed tanks, mechanized infantry, artillery, and aviation to share information in real time. The doctrine of combat commands, flexible tactical units organized for specific tasks, was only possible because all the pieces of the cog could communicate efficiently. What seemed to the Germans to be a well-trained orchestra was actually a distributed system, operating under a network logic. Each node knew where the others were. Each element could adapt. Each error was corrected in real time. On the surface, the Sherman was only a medium tank, but internally it carried a command infrastructure that transformed it into something bigger. It was not an isolated vehicle. It was a unit of a larger nervous system. Germany never understood this, and when he began to understand, it was already too late. In a German technical report captured in September 1944, one officer writes, "American tanks all seem to be capable of transmission. This cannot be underestimated." It was the beginning of a suspicion, but the real extent of the system still escaped the Wehrmacht's comprehension, because what the Americans were building was not just a better-equipped army, it was an interconnected force, and in the next battle, this system would show its true face, a place where the desert was just the rehearsal. The definitive proof would come soon, in the valleys of Italy, where German AM radios would leave tanks blind and deaf, while Shermans talked to each other across the mountains. The SCR-508 wasn't just a radio, it was a command system attached to the armor of a tank. Its BC604 transmitter operated between 20 and 27.9 MHz, delivering up to 25 watts of power with crystal-clear stability. Each unit came with 10 preset channels and instant switching, no need for manual tuning in the field. In contrast, the German FUG5 operated in the 27 to 33, 3 MHz range with only 10 watts of power and adjustment by variable capacitors, extremely sensitive to heat, vibration, and electromagnetic interference. While American radio maintained clear communication up to 10 miles in the open field, the FUG5 barely reached 1 to 2 miles on the move, and this detail, ignored by German planners, would become a difference of life and death. Sherman tanks with SCR-508 could, for example, receive aerial reconnaissance information and, seconds later, pass on coordinates to the artillery, all without moving from their place. The commander could hear the platoon channel, take orders from the battalion, and even send signals to the infantry with integrated field phones. It was a continuous data stream, where every element in the field could act as a sensor, transmitter, and executor. Radio had turned the Sherman into more than a tank. It was now a smart node of a mobile, armed network. The United States Army no longer operated with fixed formations. It operated with decentralized intelligence, where authority did not depend on hierarchical position, but on real-time information. On the field, the difference translated into lethal efficiency. During an advance, a tank spotted an enemy position and, at the same time, called in support fire, redirected platoon mates, requested air cover, and corrected routes. Within minutes, the enemy was being hit by multiple vectors, while their own tanks awaited orders that didn't arrive. The superiority of the SCR-508 was not only technical, it was systemic. It allowed coordination without eye contact. It allowed tactics without the presence of the commander. It allowed adaptation even when the original plan failed. And meanwhile, the Germans tried to win with a doctrine stuck to the logic of 1939. The FUG5, in addition to being weak, was vulnerable to any electromagnetic noise. Every spark in the engine, every electric discharge generated static. The voices were lost between hisses and echoes. German operators often had to repeat orders 3 or 4 times. In combat, this was fatal. Most tanks still use the FUG2, a simple receiver, no responsiveness, just listening, and if the commander was destroyed, the net would break completely. Meanwhile, the SCR-508, with its stabilized power supply and noise filters, transmitted human voice with full clarity even under bombardment. He didn't just survive the chaos, he walked through it. American standardization allowed any tank to connect to any other, without adaptation. A unit of the 1st Armored Division could be reassigned to support the 4th and would keep communication intact. This made it possible to create combat commands, mobile and interchangeable tactical structures, a concept that Germany simply could not replicate because its communication system was not compatible with its own doctrine of tactical flexibility. The irony was technical and profound. The United States had designed a radio not for engineers, but for soldiers, a piece of equipment that worked under dust, mud, impact, and noise, and that it did so on an industrial scale. Motorola didn't deliver radios. It delivered replicable robustness. Each Sherman tank left the factory with its radio installed, tested, and aligned. It was not an additional piece of equipment. It was part of the gun, and while German engineers tried to calibrate capacitors by hand, Americans distributed radios by thousands, all identical, all reliable, all ready to operate on the front. This difference in approach, between the artisanal engineer and the production engineer, explained why Germany had better tanks but the United States had a more effective army. American technology did not seek to impress by its complexity. She sought to win through consistency. And he won, not with bigger cannons but with clearer voices. In 1943, the communications commander of the 10th Panzer Division wrote an internal report in which he stated, "The American tactical response appears to be simultaneous to the attack. There is no noticeable reaction time. This indicates discipline or some other unknown form of coordination." They did not yet understand that they were facing a force that operated in real time, where every decision did not have to go through a chain of command, because the chain itself had been transferred into the ether. But this advantage was still invisible to much of the German command. They knew they were losing battles, but they didn't know why. And while they theorized about the morale of enemy troops or the weaknesses of the commanders themselves, they ignored the most obvious fact. The Americans had turned every tank into a decision transmitter. And in the next campaign, that advantage would become even more devastating. Because in the mountain valleys of Italy where the hills drowned out German radios, the Sherman tanks would talk, as if they were side by side. The German armored doctrine, conceived by Heinz Guderian in the 1930s, was a pioneer in recognizing the importance of radio in modern warfare. He argued that a mechanized army would only have real advantage if its elements could communicate in real time. However, the principle that he himself established was ignored when it mattered most. In 1943, the Wehrmacht's doctrine was still rigidly hierarchical. Each tank platoon, consisting of 5 vehicles, had at best 2 complete radio transceivers. The others operated only with receivers or in many cases without any radio at all. The order was simple. The commander transmitted, the others obeyed. But this structure, effective in training and short campaigns, showed catastrophic failures in dynamic confrontations against the Americans. If the lead tank was destroyed, and the Allies quickly learned to identify by the twin antennas, the German platoon became blind and mute. Coordination disappeared in seconds. The rest of the group was forced to retreat, or more often than not, to improvise in silence. This limitation was not just technical, it was ideological. Germany was betting on mechanical superiority, discipline, and pre-planned execution. The tanks didn't have to talk. They just had to obey. This belief, established since the Blitzkrieg in Poland, has become dogma. Even after the initial clashes with American radios in North Africa, internal reports downplayed the importance of communication superiority. A memorandum dated May 1943 from the technical section of the Wehrmacht stated, "The radio communication of the Anglo-Americans is efficient but not decisive. The human factor and armor still prevail." This assessment proved tragic. The human factor was prevented from acting if it could not hear or be heard. The German command structure depended on pre-orders, gestures, flares, and expectation. The Americans, on the other hand, operated in a network. If one unit entered combat, it alerted the others. If the situation changed, so did the plan. The flexible combat doctrine, the combat commands, allowed platoons, companies, and battalions to regroup in real time. There was no need for central approval. The voice, transmitted clearly by radio, was sufficient. The American lieutenant in a valley could coordinate artillery, relocate tanks, and call for air support with a single command. Meanwhile, his German counterpart had to wait for the messenger or leave the shelter to wave a flag. That's when there was eye contact. German rigidity had deep roots in the Prussian culture of order, hierarchy, and centralization. Radio was seen as a tool, not as part of the weapons system. This view limited the distribution of the few transceivers available to command vehicles, assault guns, lead tanks, and mobile outposts. The cost, the scarcity of materials, and the fear of tactical disorganization prevented the spread. In contrast, the Americans standardized. Every Sherman, even the simplest, received an SCR-508. There was no distinction between those who commanded and those who executed. Everyone was talking. Everyone listened. Everyone could act. The irony of this story is that the solution was in front of them. Guderian, who had insisted on radio as a pillar of mechanized warfare, saw his own doctrine become unrecognizable within a structure that prioritized larger tanks and longer guns, rather than cohesion. If you're enjoying unraveling these facts and understanding how invisible decisions shaped the war, show your support. Like and subscribe. It helps us keep bringing you detailed analytics like this. Throughout 1944, even in the face of mounting evidence of American responsiveness, the German leadership still treated the issue of communication as secondary. Instead of reformulating their tactical structure, they preferred to invest in heavier tanks, such as the Tiger IIs, true mobile fortresses, but which moved in isolation and almost always without effective coordination between them. It was like building castles in the open country, surrounded by silence. American ambushes were relentless. The Shermans, networked, moved like swarms, compensating for armor inferiority with tactical intelligence. The Germans, with their decentralized front line, continued to trust that strength and discipline would suffice, but they were facing a force that didn't just fight. It fought back. She adapted, and he did it in seconds. In January 1945, a report by the German Army High Command finally admitted, American armored units demonstrate superior tactical coordination. This ability cannot be explained by training alone. The realization came too late, because at that time the American network was no longer just terrestrial. She had climbed the valleys and mountains of Italy, where German radios failed completely. And there the Sherman spoke with absolute clarity. The North African desert was the first real testing ground for the SCR-508. Operation Torch, launched in November 1942, marked the large-scale entry of U.S. armored forces into the African theater, and with them, the arrival of Sherman tanks equipped with frequency-modulating radios. For the Africa Corps, this new presence seemed, at first, of little concern. The Germans still viewed the Americans as amateur fighters, dependent on British supplies and without doctrine of their own. But the desert would soon belie this arrogance. The barren open terrain did not favor static tactics. Sight lines were easily lost. Clouds of sand covered entire formations, and dust from engines rendered many of the Wehrmacht's optical systems and visual beacons useless. It was in this environment that the SCR-508 revealed its strength. For the first time, a mechanized army operated with full awareness of its own movements, even without eye contact. Tank platoons crossed dunes at different angles, maintaining adaptive formations in real time. One platoon advanced on one flank, the other retreated. The third requested artillery by grid coordinates, all in a matter of seconds. FM radio operators heard instructions with absolute clarity, even with the engines at full speed. The chaos of the desert became legible because American tanks could communicate within it. Meanwhile, German tanks operated in enforced operational silence. With AM radios highly sensitive to electromagnetic interference, their communications often became inoperable. The engine's own movement generated enough noise to interrupt transmissions, and since only 1 or 2 tanks per platoon were equipped with full transceivers, the rest had to follow prearranged orders or wait for manual signals, an almost impossible task amid the dust and speed of the American maneuver. A panzer commander could not know in real time what was happening beyond his line of sight. He could not call for help, report an open flank, or adjust the plan of attack, and when the formation was broken, the unit lost cohesion. A report from the 15th Panzer Division dated February 1943 describes the situation with frustration. Limited visibility and difficulty in communication preclude any attempt at fluid maneuver. The Americans respond too quickly. They change their position before we can complete an order. What the Germans called a tactical maneuver was, for the Americans, routine radio. The difference was also visible in the joint actions. During the clashes around Gafsa and Spatla, the American forces showed a new capability: coordination between tanks, artillery, and mechanized infantry with precision to the minute. A tank advanced, encountered resistance, and the response came in 2 channels: ground reinforcement by a neighboring platoon, and indirect fire cover by 105mm howitzers positioned miles behind. The entire chain of action was possible because the radio network was active, integrated, and reliable. An American soldier from the 1st Armored Division recorded in his diary, "It seems that the Germans only react after everything has happened." He didn't know it, but he was describing the bankruptcy of the centralized command model in the face of networked warfare. German intelligence in turn began to notice. Signal intercepting units, such as the Fernmeldetruppe, picked up American transmissions with unusual clarity. Not only did they understand the commands, which were often transmitted without coding, but they noted their fluidity, frequency, and range. One of the reports intercepted by the Abwehr read, "American mechanized units maintain contact even under intense movement. There seems to be horizontal communication, not just vertical communication." This observation, while correct, was treated with skepticism. Germans still interpreted mobility as disorganization, but what they saw was, in fact, functional decentralization, a system in which authority was distributed and intelligence was shared in real time. The desert showed on a practical scale that the war was changing. It was not enough to have a tank with thick armor or a high-velocity gun. It was necessary to know where the enemy was, where the Allies were, and how to respond before the moment passed. The Germans were stuck in a model where command dictated everything, and where the absence of command meant paralysis. The Americans, on the contrary, created autonomous networks of action. Each tank commander was both executor and censor. Each platoon was a cell capable of deciding, reacting, and coordinating. And this was only possible because the radio was no longer an extension of the command system. He was the system itself. The American defeat at Kasserine in February 1943 led many Germans to underestimate what they had witnessed. They judged the retreat as a sign of weakness, but the most attentive saw something else. A captain of the 10th Panzer Division in his internal report described, "They move with more speed than their tanks allow. They change positions before being flanked. There seems to be someone coordinating, but we don't see who." This absence of a focal point was the very essence of the American advantage. The Germans were looking for a visible command center, and they couldn't find one, because the real center was diffuse. It was the network. It was the SCR 508. The desert was the first sign, but it was not yet the final blow. What the Germans saw in Africa was only the beginning of the transformation. The next chapter would reveal something even more disturbing, that the Americans knew how to operate under broken terrain, hostile weather, and zero visibility, and yet maintain perfect cohesion. Because while German radios died in the mountains of Italy, the Shermans spoke as if they were in the open field. And it was there, among valleys and ruins, that the invisible superiority became incontestable. The signals were in front of them, clear as the intercepted radio transmissions, but the doctrinal blindness of the German high command precluded any correct interpretation. As the campaign in Tunisia progressed, and later in the mountains of Sicily and the valleys of mainland Italy, Wehrmacht intelligence units began to register an unsettling pattern. The Americans responded too quickly. Their armored units moved as one body, even when dispersed for miles. Their counterattacks arrived before German troops finished their initial advance, and most disturbingly, they seemed to know exactly where the enemy elements were, even without line of sight. The March 1943 report of the 10th Panzer Division highlights, American armored units demonstrate an unusual degree of coordination between platoons. Effective communication is observed even in progress. Extensive training is assumed as probable cause. The conclusion was typical. Recognized effect, wrong cause. The Germans saw the performance but ignored the stage where it was staged. A network of frequency modulating radios that, in effect, created a collective organism in the open. By reducing the issue to discipline and training, they missed the real source of American power, the communications infrastructure embedded in each vehicle. For German doctrine, a tank was an autonomous unit subordinated to visual and hierarchical command. The coordination was vertical. The radio, an elite tool, limited to command vehicles, treated as a technical luxury and not as a basic necessity. A commander transmitted. The subordinates listened, and if the command vehicle was destroyed, the chain broke. In contrast, the Americans standardized their communication. Each Sherman was equipped with a complete SCR-508 radio, with transmitting and receiving capability, preset channels, and crystal-clear frequency stability. There were no blind tanks among the Americans. Even the most isolated unit in an Italian valley could issue an alert, call for backup, call in artillery, or transfer command of the operation, all in real time. It was the difference between a force that operated like a tuned choir and another that improvised without a score. The Germans listened to the broadcasts. They knew something was wrong, but they didn't know what. Preserved excerpts from intercepted communications show a clarity that their own radios could not achieve even within visual range. A Fernmeldetruppe officer recorded in April 1943, American transmissions are of unusual technical clarity, almost non-existent noise, above-average operating distance. Frequency does not seem to match AM patterns. But again, the diagnosis did not lead to understanding. The use of frequency modulation, superior for environments with noise, vibration, and mobility, was still a novelty outside American technical circles. Wehrmacht engineers were aware of the technology, but considered it impractical on a field scale. The cost of manufacturing, the stability of oscillator crystals, the sensitivity to temperature, all seemed like an insurmountable obstacle to an industry in constant shortage of materials and under bombardment. But America didn't just overcome these challenges, it industrialized them. Motorola delivered thousands of SCR-508 units with millimeter accuracy and continuous reliability. Each radio was tested in field simulations. Every component was replaceable. Every tank that left the lines of Detroit was automatically a functional node in the Army's tactical network. It was the triumph not only of technology, but of production at scale. And, as a final irony, this same scale prevented the enemy from understanding the phenomenon. Germany, locked in a war of material attrition, assumed that the Americans were just putting more tanks in the field. They didn't realize that they were putting more intelligence, more connectivity, more responsiveness. In other words, they were putting up nets. The tactical consequence was visible in battles, but invisible on maps. When an American company retreated, it was immediately replaced by another that already knew the enemy's exact position. When a platoon ran out of ammunition, a coordinated request triggered an automated supply chain. When the attack came from an unexpected flank, all it took was one call for the entire line to be redrawn in minutes. The radio was not just a tool, it was the nervous skeleton of an army that could think in real time. And the Germans? They still expected a tank to be ordered by flags or flashing lights in the open field. The irony of this historical blindness is that the signs were all there. The interceptions showed. The reports from the front indicated. The POWs confirmed. Each American crew spoke to the others. Each tank was a sensor. Each platoon, a living cell. But German doctrinal reasoning did not allow the idea that a technology could replace hierarchy. It was the triumph of the engineer over the official, of the system over individual authority. And Germany, despite having invented the Blitzkrieg, was now waging a 20th century war with 19th century eyes. Later, when questioned by Allied officers, several panzer commanders would admit their surprise. One of them, whose name has been lost in the post-surrender archives, said with frustration, "We believe they had radios, but not that everyone did." That sentence sums up the central error. It wasn't a matter of owning the technology, but of distributing it universally. The Germans had radios. They had powerful tanks. They had doctrine, but they lacked the element that made all this coordinated, simultaneous, and lethal. And if in Africa the Sherman's communication seemed miraculous, in the mountains of Italy it would become unsurpassed. The geography that was supposed to neutralize radium, with deep valleys and rocky ridges, only reinforced the American advantage, because while German AM radios fell silent in the face of echo and reverberation, American FM radios continued to function. And there, among the fog of Monte Cassino and the wreckage of the Gustav Line, the enemy finally realized what the Americans called coordination, the Germans still called luck. But luck at that point in the war already had a defined frequency, oscillator crystal and 25 watts of power. Normandy, June 1944. Sherman tanks left the beaches with the confidence of those who mastered an invisible technology. Every vehicle connected, every platoon in contact, every commander listening to multiple frequencies at the same time. But this web of communication ran into an unexpected obstacle: the American infantry itself. As the tanks entered the green labyrinths of the French bocage, with its impenetrable hedges and narrow trails, the supremacy of radio found a new enemy: silence among friendly forces. The Sherman's SCR 508 radios operated between 20.0 and 27.9 MHz, while the infantry's SCR 300 radios, portable and limited, operated in another band, from 40.0 to 48.0 MHz. The consequence was immediate and deadly. The tanks advanced without knowing where the infantrymen were, and these, in turn, could not warn the armored vehicles of the presence of German hunters with Panzerfausts waiting in the hidden corners. Contemporary accounts describe tanks destroyed by surprise attacks within a few feet of American soldiers who could not warn their comrades protected by tons of steel, but isolated by mismatched megahertz. It was a moment of operational shock, a failure that cost lives and exposed a critical gap. But it was also a test of the real American differential, the ability to adapt in real time. Within days, the solution emerged not from engineers in laboratories but from soldiers in the field. Tankers began to improvise. They took EE-8 model field phones, connected wires directly to the tank's internal system, welded ammunition boxes to the side of the vehicles, and created a point of physical contact between the infantry and the armored crew. All you had to do was lift the lid, turn the crank, and talk to whoever was inside. Improvisation became doctrine. The Army standardized the device. Over the next few weeks, thousands of tanks began carrying these external infantry phones, a simple, crude but brilliant solution. On a battlefield where frequencies did not intersect, a steel cable bridged the gap between two forces that needed to fight as one. The impact was immediate. Field reports show a leap in the effectiveness of coordinated actions. The infantry could request cover of fire in seconds. The tanks could confirm clean zones. Ambushes began to be avoided. The fusion between internal radio and external physical contact gave rise to a new form of integrated command, born of necessity and nourished by flexibility. It is this kind of response, rapid, creative, almost anarchic, that differentiates the American model of industrial warfare from the German model. In the Wehrmacht doctrine, changes required authorization, approval, revision. In American practice, the sergeant in the field decided, and the structure adapted around him. Pause for a fact that the Germans never understood. In just 4 weeks after the Normandy landings, more than 2,500 Sherman tanks were modified with EE-8 infantry external telephones. No German tank has ever received anything similar. If you were surprised by this speed of adaptation, write in the comments, "Logistics wins." Because, in fact, at this point in the war, logistics had already become the main American weapon. On the other side, the Germans watched in bewilderment. Their own tanks were superior in armament and armor. The Panzer IV and Panther could destroy a Sherman with a single shot, but this tactical superiority was nullified by strategic disorganization. While the German infantry had to race to find an officer who had a radio, and even then could not speak, only listen, the Americans improvised, connected, and decided in seconds. The irony was cruel. Germany, creator of the mobility and communication-based blitzkrieg, now operated deaf and blind, trapped in structures that refused to change. The Americans, on the other hand, even in the face of glaring failures, reacted with speed, ingenuity, and integration between tactical and strategic levels. The introduction of the EE-8 phones marked an important transition. It was not just a matter of solving a technical problem, but of preserving the central principle of the American war: connectivity. No unit could be isolated. No tank could be left without a voice. If the radio wasn't enough, the wire would do the trick. And if the thread was not possible, another solution would emerge. The important thing was to keep alive the decentralized decision-making network that allowed each soldier to act with information, not instinct. This philosophy of data-driven action would be carried forward, expanded, and transformed into formal doctrine in the following decades. But here, among the hedgerows of Normandy, it was written with weld, wire, and blood. The European battlefield required more than firepower. It required the ability to see beyond the next hedge. The Americans did it not with eyes but with waves, with antennas, receivers, and, when necessary, with a hand-cranked phone attached to the hull of a tank. Connection, by any means necessary, was the key, and when the Germans tried to emulate these solutions, they discovered too late that they had neither the materials nor the mindset, nor the doctrine to integrate technology into the battlefield with the same fluidity. In the following months, this philosophy would gain a new scale. Not only tanks and infantry, but also aviation, artillery, and logistics would be integrated into tactical communication networks that allowed simultaneous maneuvers tens of kilometers away. Each unit would become an extension of the other, and the radio, whether by waves or by wires, would be the common thread of a force that did not need to be together to fight as one. But this was not the pinnacle of innovation. The real demonstration of what America was capable of with coordinated communication would come a few days later, during an offensive that would use not only tanks and telephones, but also artillery, mechanized infantry, aerial observers, and naval cover, all connected in real time. The name of the operation? Snake. And in it, Germany would face something it could not fight, an entire army operating as if it were a single brain. July 1944. The narrow roads of Normandy tremble under the roar of engines. Operation Cobra is about to begin, and with it, the moment when the American doctrine of war ceases to be theory and turns into an avalanche. Within hours, more than 500 bombers would drop a curtain of destruction over the German lines around St. Lo. But what would come next was not chaos. It was precision. It was the sound of more than 200 Sherman tanks, each equipped with an SCR-508 radio, moving as if obeying the same consciousness. The advance was neither blind nor impulsive. Every armored platoon lined up with infantry sections. Every flanking movement was communicated in real time. Every obstacle was overcome not by brute force but by shared information. American artillery, positioned tens of miles away, fired minutes in advance, guided by radio-connected field observers, adjusting coordinates based on reports circulating between tanks, soldiers, and the skies. It was a war conducted by electromagnetic waves. On the other end of the line, the Wehrmacht's elite, the Panzerlehr Division, faced destruction without knowing where it was coming from. With their Tiger and Panther tanks, their 88mm guns, and their reputation intact, the Germans were ready to resist. But they were deaf. The bombardment that preceded the offensive dismantled the communication centers. Their AM radios, already scarce and vulnerable to interference, fell silent under the din of metal and earth being torn apart. When the Sherman tanks advanced, Panzerlehr was divided, with no coordination, no view of the field. A German company commander would later report, "They seemed to know where we were before we even moved. They attacked our flanks as if they were seeing through the trees." It was not clairvoyance. It was radio. It was a network. Every American move was supported by a transmission, reception, and execution system that no longer required central authorization. Tactical coordination was a distributed function, and therefore, unstoppable. The orders came from everywhere, and from nowhere. A platoon stuck on a narrow road could call for reinforcements with a click. An observer on a hill would report on enemy positions, and artillery would respond before the Germans could change places. The time between seeing and acting had disappeared, and on the modern battlefield that speed is more lethal than any cannon. The operation advanced miles in a single day, breaking through the center of German resistance. The Panzerlehr, considered one of the best trained divisions in Hitler's army, lost more than half of its armor in the first 24 hours, not because of mechanical inferiority, but because she was fighting against a system that adapted every second, while she kept waiting for orders that never came. The radio here proved to be more decisive than the shielding, more lethal than artillery, because he allowed each unit to be an eye, an ear, and a voice. An army of thousands of us, all interconnected. Germany, with its doctrine based on visual command and hierarchical execution, was reduced to fragments, unable to react in real time. At the end of the operation, Panzerlehr Commander General Fritz Bayerlein would write, "There was no front line. Everywhere we looked, the Americans were already there." This sense of omniscience was not supernatural. It was technical. It was radio. It was the direct consequence of treating communication as a central part of the doctrine and not as an accessory. That day, more than tanks, it was the signals that advanced. Operation Cobra was the practical proof of a truth that the Germans had refused to see since 1942. The battlefield of the 20th century belonged to those who mastered information, and the Sherman's FM radio, silent, accurate, reliable, had transformed the U.S. Army into something that could not be destroyed in parts, because each party knew what to do, even when it was alone. But the true impact of all this would only be felt when the mature network began to integrate with aerial artillery, strategic bombardments, and automated logistical advances. And on this new board, the Germans still played with separate pieces, while the Americans finally unified the entire game. By September 1944, the camps of East France offered a new kind of war, not a war of armor or caliber, but of decisions, of initiative. And there, the American army would present a weapon that German doctrine was not prepared to face: lethal decentralization. The idea that every tank, every platoon commander, every soldier with a radio could make autonomous decisions based on real-time data. The Germans for years had invested in a precise logic: destroy the command tanks. Their manuals taught that by neutralizing the leader, the only one with a radio transmitter, the entire enemy platoon would become harmless. This is how its own structure worked. Only the vehicle of leadership could issue orders. The others, in many cases, did not even have a radio, or they only received it. When the head fell, the body died with it. But the U.S. Army had subverted that logic. By standardizing SCR 508 radios on all Sherman tanks, any vehicle could take tactical control in the field. If the commander fell, the sergeant transmitted. If the platoon dispersed, the tanks would regroup in minutes, without relying on orders from afar. It was a distributed network, where the death of a node did not compromise the system. It was, in practice, a war without a focal point. In battles such as that of Ericourt in September 1944, this philosophy proved its strength. An American task force was ambushed by a German armored detachment superior in numbers and tonnage. The command tank was hit in the first few minutes. Under normal conditions, or rather by German standards, this would mean the collapse of the formation. But the remaining Shermans reacted accurately. A subordinate tank took over the command channel. He repositioned the units, called in reinforcement by radio, and directed a counterattack with artillery support. In 30 minutes, the roles were reversed. The Germans, trapped in dependence on visual orders and rigidity of command, hesitated. When they lost their leadership vehicles, they came to a standstill. The Americans, on the contrary, multiplied their intelligence. Because information was not the monopoly of a single official, it was part of the DNA of each unit. This was the central error of German doctrine, believing that command is a point. The Americans showed that command is a flow, and that the radio, standardized, reliable, decentralized, is the conductor of this flow. Panzer divisions, even with technically superior tanks, became vulnerable to this logic. A commander of the 2nd SS Panzer Division recorded in his diary after the fighting in the Ardennes, "We attacked the flank and destroyed the lead car. We expected a retreat, but they regrouped before we finished the advance." This surprise reveals the collapse of German logic. What was supposed to be a decisive blow became only the beginning of a new configuration. Because, contrary to German doctrine, which treated the field as a hierarchical chessboard, the Americans saw it as an organic system, where every cell could adapt, react, and command. The term lethal decentralization began to emerge in post-war textbooks, but its essence was forged there. on the muddy roads of France, in the valleys of Belgium, on the makeshift flanks of the Hurtgen forest. The combination of reliable FM radio, flexible doctrine, and distributed initiative turned the Shermans into more than tanks. They became mobile command transmitters. Each crew had not only ammunition, but information, and this, in war, is worth more than any armor. It is important to remember that at the time the Germans did not understand this concept, and for this reason, they insisted on the selective destruction of leaders, the capture of documents, the neutralization of command centers. It was a mentality of vertical warfare, where victory came by decapitating the enemy. But against an opponent without a fixed head, who could think with any part of his body, this tactic failed. The American network didn't just resist the blows, it learned from them. Pause for a fact that summarizes this turnaround. In 1944, more than 85% of the Sherman tanks in operation in Europe were equipped with fully functional radios, with transmission and reception capacity. In the Wehrmacht, only 18% of medium tanks had full radios. The rest depended on direct vision or visual cues. If this number surprised you, write in the comments, "Shocking data," because this difference, almost invisible in the books, was decisive on the battlefields. Radio in its essence has nullified the concept of isolated unity. No Sherman fought alone. Even damaged, even surrounded, he was part of a network. It could transmit coordinates. He could report the enemy's position. He could call for cover fire or request evacuation. And this network, alive, adaptive, redundant, meant that the destruction of a commander did not mean the loss of a combat. It meant only a reconfiguration. A new point of leadership emerged, and the offensive continued. It was war shaped by waves. Germany, with all its military tradition, was slow to realize this. Their tanks were built as mobile fortresses. The Americans built them like us from a system. And when the fortresses lost their tower, they collapsed. The nodes, even under attack, kept the network pulsating. War ceased to be a dispute between vehicles and became a dispute between structures. And there, the American industrial, technical, and communicative model proved to be superior. But if Sherman tanks formed the backbone of the network, there was yet another element that would complete the system, an air link that would allow the sky to hear as well. Because when planes, tanks, and artillery began to operate at the same frequency, the war became a real-time simulation, and what was to come, in the open plains of West Germany, would turn the notion of blitzkrieg into a distant memory. For centuries, combat power has been measured in steel and fire, the size of the gun, the thickness of the armor, the strength of the engine. These were the criteria that defined who would win a duel on the battlefield. But something changed in World War II, and few noticed in time. The radio, until then seen as a communication accessory, became the de facto weapon system of the American Sherman tank. He did not fire projectiles, but projected decisions. He did not protect with steel, but in advance. He did not break the enemy with force, but with coordination. The war there began to change axis, from the platform to the network. The SCR-508, installed in each Sherman, now represents more than one voice channel. It was the vector of a distributed intelligence, capable of transforming a set of tanks into a military organism that thought, reacted, and counterattacked with a speed that the Germans could not match. While European doctrine still relied on armored vehicles as gladiators, each one for himself commanded from above, the Americans had attached to each vehicle an antenna that connected it to a collective brain. The platform was no longer the center of strength. The cannon was no longer the final argument. It was the radio that decided who fired first, from where, with what support, and with which rear guard. This change was not just tactical, it was conceptual. The Sherman tank, considered technically inferior by German standards, survived and won precisely because of its integration into the whole. He didn't have to win alone. Its power was in the whole, and the radio was the link between these groups. Each platoon could reposition, each commander could reconfigure its formation, each isolated unit could reconnect to the system. It was the birth of a new doctrine, one that would see, years later, the emergence of the terms weapons system, sensor-to-shooter, and networked command and control. But in the summer of 1944, all of this was still a practical intuition, something that American soldiers understood in the field, even if they had no words to describe it. Post-war military experts would look back and see the embryo of network-centric combat. Douglas Gourlay, a tactical analyst at the Rand Corporation, wrote in 1952, "The greatest innovation of the American Army in World War II was not a weapon. It was the systematic use of information as a force multiplier." And he was right. The SCR-5 underweight radio, with its preset channels, stable frequency modulation, and robust range, was the backbone of a command structure that did not collapse on the death of an officer. It was redundant. He was flexible, and therefore, lethal. American engineering understood that it was not enough to produce tanks. It was necessary to connect them. And for this, it created a standardized system where each vehicle left the assembly line with the same radio, with interchangeable parts, with compatible codes. It was the application of the industrial model to war, not only manufacturing a lot, but manufacturing in such a way that everything worked together. Germany, on the other hand, followed an artisanal model. Each Panther tank was technically superior, but manufactured with slight variations, with less reliable, less stable radios, with varying frequencies, and which often required manual adjustments in the field. Interoperability was limited, standardization almost non-existent. The result was a tactically powerful but strategically fragmented force, and there, among the rubble of France, this made all the difference. The comparison between the two models is revealing. German tanks won duels, but Americans won campaigns, because their advantage was not localized, it was systemic. Each American advance was preceded by a chain of decisions made in seconds, between tanks that communicated with each other as synapses of a collective brain. When a Sherman saw the enemy, everyone knew. When one flank was threatened, another covered. When a platoon needed artillery, the order was placed, approved, and executed in a matter of minutes. It wasn't brute force. It was a real-time response. It was the radio as an invisible weapon. It is at this point that the classic definition of weapons system begins to dissolve, because until then, a weapon system was understood as the junction between a launcher, the cannon, a platform, the tank, and an ammunition, the projectile. But the Second World War, especially from 1944 onwards, began to show that this was insufficient, that the real system was composed of sensors, communications, command, control, and execution, and that the radio was the thread that sewed all this. The Shermans didn't win alone. They won because they were part of a larger system, and because that system operated as a body with multiple eyes, ears, and hands. One of the most revealing accounts came from a German general captured at the end of the war, interrogated by Allied officers. When asked what surprised him most about the American operations, he replied, "You knew where we were, always, before we move." This sense of American omniscience did not come from spies or magic. It came from a functioning communication network that transmitted data clearly, that transformed tanks into sensors and soldiers into decision-making nodes. The radio allowed the battlefield to move from a chaos of movements to a living map, where every point could report, decide, and act. And if so far the focus has been on Sherman tanks, it is because they were the clearest proof that an inferior platform, when connected, becomes superior. But this model, this network logic, would not be limited to armored vehicles. What was about to happen in the skies over Germany would take this concept to a new level, where planes, ground observers, and tanks would speak the same language, at the same frequency, in the same second. And at that moment, even time would start to work for the Americans, because when you master the information, even the future arrives faster. September 1944. In the misty fields south of Nancy, the German army was preparing another counterattack with what was left of its armored reserves. It was the beginning of the Battle of Aricourt. The Wehrmacht had assembled more than 280 tanks and armored vehicles, including its dreaded Panthers, designed to technically dominate any enemy armor. Facing them was the American 4th Armored Division, equipped mostly with Sherman tanks, tactically inferior in armor and direct armament. But there, the advantage was not in steel, it was on the air. Against a backdrop of dense fog, where visibility was limited and hills cut off sightlines, German doctrine based on concentrated attacks and visual leadership began to fail. The Panthers, without clear vision and without stable communication with each other, advanced as isolated columns. The 4th Division, on the other hand, operated as a network. The Shermans, connected via SCR-508, shared positions, requested air support, coordinated ambushes, changed routes in real time. What's more, P-47 Thunderbolt fighter bombers, also radio connected to ground observers, responded to calls for support with devastating precision. In less than 48 hours, the battlefield became an invisible trap. The American artillery, guided by observers embarked on their own tanks, reached enemy armor concentrations with minimal margins of error. Each Sherman acted not only as a weapon, but as a sensor, each platoon, a data emitter. And even with the loss of command cars, the network was reconfigured in seconds. Meanwhile, the Panthers, even with their superior armor, were slow to respond. The German command, centralized and lacking redundant channels, took precious minutes to react, time that the Americans were already using to reposition, reinforce, or destroy. The result, 281 German vehicles were destroyed. American losses amounted to only 41 Shermans, a proportion that bordered on the unbelievable, given the technical contrast between the machines. This number, documented in the post-war period, became a mandatory study in command and staff schools, a statistic that Hitler's generals would never have expected to see, 281 to 41. If this surprises you, comment now on shocking data, because this was not just a tactical victory, it was a demonstration of the failure of an entire model of warfare. Germany had bet everything on mechanical superiority, but he did not see that the war had already changed its dimension. It was not enough to shoot first. It was necessary to know where to aim, and Americans knew, because they listened, spoke, and decided online. The Battle of Ericourt cemented a new form of combat. German manuals still taught how to protect the command car as a top priority. The Americans were already 2 steps ahead, distributing command in each unit, decentralizing critical functions, making paralysis impossible. Each Sherman tank, with a functional radio, was a potential decision center, a minefield of initiative. Intelligence spread like a virus, invisible, but present in every cell of the system. This episode also marked the moment when American doctrine surpassed German doctrine, not only in practice, but in theory. Until then, the Blitzkrieg had been the model of military effectiveness: quick attacks, coordination between mobile forces, breaking enemy lines. But now, the Americans were using this logic. The difference is that they had a differential. Their tanks, their artillery, and their aviation spoke to each other, and this symbiosis has become the new standard of modern warfare. A real-time coordinated force doesn't have to be faster than the enemy, just be more aware. In the post-battle analysis, German officers reported a sense of permanent encirclement, even as their tanks advanced. It seemed that the Americans anticipated them with every move. It wasn't magic. It was radio. It was logistics. It was doctrine adapted to technology. A technology that alone would not win battles, but that integrated with mass production, the standardization of systems, and the decentralization of command, made each Sherman part of a collective mind that learned and reacted. Ericourt's victory was not won by projectiles. It was decided by faster decisions. But even after this crushing defeat, many in the German command remained stuck in an illusion that there was still time to reverse the war with new weapons, more powerful tanks, super cannons, a blind faith in the platform. They didn't know, or didn't want to accept, that the platform had already been surpassed, that now the strength came from the invisible, from the air, and sound, because while they were building new weapons, the Americans were plugging in the ones they already had. And what would come next would prove irrefutably that no cannon is more dangerous than an enemy who already knows where you are. March 1945. The Rhine, the last great natural barrier before Germany's industrial heartland, still seemed insurmountable. For the German High Command, any crossing there would require months of planning, heavy logistics, and direct confrontation. That was what logic taught. That was what the doctrine required. But at 1:50 p.m., on the 7th, an American patrol spotted something that would change the course of the war. The Ludendorff Railroad Bridge in Remagen, still standing. In a matter of minutes, the information was transmitted via radio to nearby units, to divisional commands, to artillery. At 2:20 p.m., the first soldiers crossed. By 3 p.m., Sherman tanks were on the other side. By 4 p.m., the bridge was in Allied hands. What should have been a German strategic point of contention became a symbol of the collapse. Not by force, but by the speed of the decision. On the American side, everything flowed in waves: detection, transmission, command, action. On the German side, confusion reigned. Communications had been destroyed by tactical bombardments. The telephone lines were cut. The radios, still operating in AM and without a redundant structure, suffered interference, frequency disorganization, and lack of trained personnel. Officers in the field with no contact with the high command made decisions blindly. Or worse, they waited for orders that would never come. The loss of the Remagen Bridge was not just a physical defeat, it was a symbolic collapse. It represented the moment when Germany stopped listening, when the German army, already worn out and fragmented, became deaf within its own territory. The fragmentation of the communications infrastructure has meant that entire units have become isolated, unable to coordinate maneuvers or react to lightning advances. Meanwhile, the Americans, with standardized radios from the platoon to the air level, adapted every movement to the situation in real time. Radio at this point had ceased to be just a differential. It had become the very backbone of the Allied military effort, and this was reflected in the speed with which the Americans exploited the gaps. In just 8 days after the initial crossing, more than 25,000 troops and hundreds of vehicles had crossed to the east bank of the Rhine. Each movement was adjusted via radio, with tactical changes in seconds, command relays, and logistical support calls without waiting for messengers, cables, or written orders. The American tactical network was alive. It pulsated, and it advanced. On the German side, generals tried to coordinate counterattacks with divisions that no longer existed or that could not be located. Buried cables were destroyed by B-17 bombardments. Mobile antennas had been moved, but without a functional power supply structure. The Luftwaffe, already collapsing, could not even lift aircraft for observation. It was strategic silence. An army that does not listen does not command. An army that does not speak does not react. Reports from the front show the psychological impact of this collapse. German officers describe, in diaries and interrogations, the feeling of being abandoned by Berlin. But the abandonment was not political. It was technical. The command channels had been erased from the map. Major Wilhelm Schreiber, captured in April, said, "Our radios squeaked but said nothing. We were surrounded by noise, with no message." It was no longer just physical destruction. It was the disintegration of the idea of coordinated war. Germany was no longer retreating. It was falling apart. In disconnected cells, unable to cooperate, stuck to the doctrine that demanded centralization. Meanwhile, the enemy, the one who, years earlier, had been derided as slow, inexperienced, and mechanical, became a fluid entity, reorganizing itself in the field, adapting the plan in real time, and making decisions based on fresh data. This ability to adapt was decisive. And it is at this point that the story ceases to be just military and becomes structural. Equipment standardization, investment in technical training, integrated industrial production, and distributed initiative doctrine allowed the U.S. Army to function even at severe losses. It did not depend on a single center. It didn't require a single command line. Its power was horizontal, dynamic, and resistant. Each soldier with a radio was a functional cell. Each tank has an emitter. Each plane is an extension of the eyes on the ground, and because of this, each battle was a living network. By the end of March, as the Allies advanced at more than 30 kilometers a day, the Germans were retreating without even knowing where their flanks were. And here is a fact that helps to understand the dimension of this collapse. In the last month of the war, more than 60% of the German units that surrendered had not received direct orders to retreat. They simply could no longer contact the command. If this number impresses you, comment, "Logistics wins." Because this statistic is not just curious, it is definitive. Modern warfare is not won with firepower alone. You win with the ability to keep the network alive. And so, the radio, that little device attached to the inside of Sherman tanks so often ignored in post-war analyses, proved to be the most lethal weapon in the American arsenal. Because in the end, it was not the cannon that broke the German resistance. It was silence. A silence imposed by waves that the Germans never knew how to master. But the biggest error in judgment had not yet been revealed. Because while the Sherman tanks coordinated their destruction with precision, there was another weapon that also listened. And this one came from heaven. Heinz Guderian knew that tanks alone were just steel on tracks. Since the end of World War I, he had envisioned something greater, not a weapon, but a system. In his 1937 book, Achtung Panzer, Guderian already clearly described the essence of modern warfare: mobility, coordination, and communication. There, between technical paragraphs and emerging doctrine, he left a phrase that would sound prophetic. The radio is the link without which armored divisions are nothing more than blind herds. And yet, when war finally broke out, that lesson was forgotten by those who should have protected it most. Germany in 1940 invaded France with lightning efficiency, it is true, but already there, the germ of contradiction was planted. Radios were still limited, installed only in the command tanks. The rest operated with hand signals, flags, assumptions. It was as if the machine conceived by Guderian had been adopted, but his brain had been left behind. And contrary to what post-war myth would maintain, the Blitzkrieg was never sustained by full real-time coordination. It was audacity, speed, and improvisation, not system. Meanwhile, in the United States, a nation regarded as slow, distant, and industrially crude, someone had read the same book, and he understood something that the Germans themselves ignored. When the first Sherman tanks began production, the U.S. Army did not discuss whether the radio would be an accessory. It was designed as a key part of the vehicle. Each armored vehicle left the factory with an SCR-508 installed as standard, each platoon trained in networked command doctrine. The vision that Guderian had in the 1930s of tanks as part of a thinking, interconnected unity has been realized, but not by him, and not by Germany. The architect of modern warfare would live to see his project surpassed by those who took it more seriously than his own country. In a post-war interview during his detention, Guderian was confronted by an American officer. The latter asked him how he evaluated the performance of communication in German armored operations. Guderian, after a long silence, replied, "We lacked not the idea, but the application." It was more than a confession. It was a bitter observation. The doctrine he had conceived had been treated as an aesthetic inspiration, but not as a structural guideline. And when the Allies implemented this idea with industrial discipline and systemic vision, the result was overwhelming. The irony is complete when one observes that Germany during the war still produced tanks superior in technical performance. The Panther, the Tiger, the Jagdpanther, machines that one by one outmaneuvered the Sherman in direct combat. But the battlefield was no longer a ring. It was a system, and in this system the one who won was not the strongest, but the most coordinated. The U.S. didn't just produce more tanks, it produced a logic of operation, and it included the radio as a nerve center. While the German army insisted on commanding from the top, the Americans spread command among their units. Each radio station was a seed of initiative. This detail was often minimized in classical studies. But today, modern military doctrines, such as the concept of mission command or distributed force, recognize that it was there, in the massive, intelligent use of radio, that modern warfare was born. Not armored warfare, but network warfare. Guderian's doctrine, appropriated, improved, and applied by the Americans, had become a weapon, one that he no longer controlled. And herein lies the bitter lesson. Germany, the forger of the theory, was defeated by its inability to follow it. The United States, considered naive by many German theorists at the beginning of the war, showed that true power lies not only in inventing, but in knowing how to implement with scale, discipline, and vision. At the end of the conflict, Guderian observed a world that had accepted his ideas, but with other generals, in another language, under another flag. World War II didn't just redefine borders, it redefined authors. And among the rubble of Europe, an old German theoretician saw his doctrine triumph in the hands of the enemy. But what he would never have imagined is that, on the other side of the Atlantic, a new generation was already preparing for the next leap, where not even radio would be the limit, because the war was already moving towards space above the clouds, and the eyes that would appear there would be even more lethal than the voices. The victory that was consolidated on the fields of Europe began long before the first explosion. It began in silence, in the creaking of Chicago gears, in the metallic heat of Newark, in the millimeter compass of the drawing boards in Fort Wayne. It was there that the United States waged the real war, not against soldiers but against time, scale, and variability. The mass production of the SCR-508 radio fitted to virtually all of the 49,324 Sherman tanks manufactured during the war, was a feat that few historians recount with due reverence. More than 50,000 units of the SCR-508 were produced between 1941 and 1945, all to a strict technical standard, with tolerances that allowed immediate interchangeability between units, without the need for recalibration. This meant that anywhere on the globe, a spare part could be shipped, installed, and operated without adjustment, something Germany, with its obsession with craftsmanship, could never replicate. And here begins the irony. The country of improvisation created the most standardized system of war. The nation that the Germans judged to be technically inferior built a production ecosystem where each piece was part of an invisible but indestructible whole. The SCR-508 was not only functional, it was resilient. Its components withstood extreme variations in temperature and vibration. The equipment operated at frequency modulation, which drastically reduced interference, a critical problem on the battlefield, where engines, power lines, and even artillery fire could distort signals. The frequency was kept stable even with the violent movement of the tank. The channels were preset and could be changed in seconds. And more importantly, everyone spoke the same language. From platoon to divisional command, through artillery to the Air Force, communication flowed because industry had done the impossible, integrating doctrine, design, and assembly line. In contrast, Germany, despite its technical excellence, went down another path. Their radios, such as the FUG5, were fragile, dependent on specific parts, difficult to maintain in the field, and in many cases incompatible with each other. Only about 6,000 complete transceivers have been produced for the more than 12,000 medium and heavy tanks in operation. This meant that half of the armored force operated in virtually the dark, taking orders but unable to respond to them. And even those that received and transmitted often suffered from interference, low emission power, and lack of adequate technical training for operators. The doctrine that called for centralized command did not receive from German industry the means to survive on a chaotic battlefield. Meanwhile, in the U.S., companies such as Galvin Manufacturing Corporation, which would become Motorola, worked in 3 shifts, employing more than 20,000 workers, including engineers, laborers, and technicians. Women represented 30% of the production force in the electronics sectors. Each batch of radios was tested in field simulations, and new operators received detailed manuals, radio instructions, and even hands-on training with real tanks at test bases. Radios were packed with spare parts, cables, instructions, and tools, all designed to work under stress, all calculated to be used by young, tired soldiers with often little time of instruction. American industry didn't just produce a radio, it produced a survival system. This ability to think of war as a process, and not just as a confrontation, changed the course of history, because while the Germans had elite units, the Americans prepared the set, each platoon with its radio, each tank with its redundancy, each commander with his network. The war was won not in the field but in the factory, not with projectiles but with patterns. And the irony of this story is that the solution was in front of them. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can bring you more in-depth content. This difference between the obsession with artisanal excellence and the search for systemic excellence defines the great lesson of war. The U.S. Army, often inferior in individual armament quality, was superior in something more decisive, the ability to function as an organism. And that organism was fueled by factories that understood that every button soldered, every capacitor tweaked, every connector tightly fitted, was ultimately a life-or-death decision thousands of miles away. There was no glamour, but there was precision. There was no applause, but there was a result. Sherman tanks, so often ridiculed for their thin armor and modest gun, proved that an ordinary vehicle, when inserted into an extraordinary network, becomes a lethal weapon. By the end of the war, captured German reports show a constant concern for tactical coordination of the Americans, which was considered impossible to replicate at the present stage of the war. And it wasn't just the doctrine, it was the industrial base. Germany had neither the materials, nor the scale, nor the time to produce what the U.S. had already distributed around the world. And so once again, superiority did not reveal itself in hand-to-hand combat, but at the moment when the factory and the front became one. But even with all of this, there was still one element that would make this system even more deadly, because what the tanks saw, it was just part of the story. And the last piece of this puzzle would come from the sky, with eyes that not only saw but guided. In the heat of combat, the distance between life and death is measured in seconds and in silence. For American veterans, that fine line was often crossed not by steel but by voice. The radio, embedded in the stuffy interior of a Sherman, emitted more than orders. He conveyed presence. It conveyed existence. It was common to hear veterans say that even when separated by hills, smoke, or destruction, they knew they were not alone. The simple confirmation that another platoon was responding, that the command was listening to them, that an artillery request was on the way, changed the way they faced fear. An operator of the 3rd Armored Division wrote in a letter, "When everything shakes and you see nothing, the voice on the radio is what anchors sanity. It's proof that we're still part of something. This invisible connection, which the engineers called a signal, the soldiers called a company. It was the emotional thread that connected men in steel to other men in steel, but also to something bigger than all, the sense of belonging and responsiveness." In the German tanks, the scenario was different. Radio, when it existed, was technical, utilitarian, limited. The doctrine did not provide for quick answers nor encouragement of individual initiative. The reports collected from Panther and Tiger crew describe loneliness as a constant element. When the command tank was destroyed, the platoon fell silent. When contact with the rear was cut off, hesitation set in. Without orders, without coordination, the soldiers were at the mercy of luck or rigidity. A German commander, in a captured diary, summed it up with a bitter phrase: "The armor is thick, but fear enters through the gaps of silence." The confidence in both armies was not only in the equipment, but in what it symbolized. For Americans, the radio was more than a transmitter. It was a link, a bond between voices, battalions, and hopes. This difference is not just technical. It reveals a profound contrast in operational culture. In the U.S., mission doctrine allowed for flexibility. The soldier could act, react, adapt, and the radio was the medium that validated his autonomy. The German war machine, on the other hand, despite discipline and refined technique, was built on centralized control. The silence, therefore, was not just the absence of sound, it was a lack of permission. In the midst of the chaos, the Americans could improvise. The Germans, wait. And this detail, so often forgotten among the equipment lists and battle numbers, was decisive for combat morale. The psychology of war teaches that isolation is one of the most destructive forces in the field. Disconnected soldiers tend to inertia, panic, disorganization. On the other hand, those who know that they are inserted in a mesh, that there are others listening, responding, acting, face chaos with a different posture. That was the real secret of American radio. He didn't just inform, he supported. When a Sherman was hit, the crew knew that the command would hear the last signal. When a platoon advanced on blind ground, it knew it could call in air support. When confusion set in, there was a safe frequency where clarity was possible. This kind of faith, built not on speeches but on successive tests of response, was the invisible cement of combat morale, and this faith had direct consequences on tactical effectiveness. American crews risked daring maneuvers because they knew they were not acting alone. Gunners aimed better because they received information in real time. Commanders made decisions based on a dynamic board, not outdated maps. It was a war on the move, and trust was fuel. The Germans, on the other hand, often hesitated, not for lack of courage but for lack of context. Not knowing what lay beyond the hill, they waited. Without confirming the position of the Allies, they retreated. Radio's superiority wasn't a matter of power or range, it was a matter of time. And in modern warfare, time is the only currency that cannot be recovered. Once again, the numbers support this difference. In 1944, estimates from the American OSS indicated that 98% of American armored units had a functional radio. On the German side, internal reports indicated that less than 50% of operational tanks had full transceivers. This meant that for every American unit capable of acting in a network, there was an isolated German unit, dependent on visual line or assumptions. If this difference was already tactical, the psychological impact was even greater. Knowing that he could call for help, that his position was known, that a retreat could be organized, that wasn't just command. It was hope. Faith in connection did not come about by chance. It was cultivated by an industry that believed in standardization as a form of power. for a doctrine that allowed initiative, and by soldiers who, when living this network in practice, never wanted to return to silence. War is made of steel, gunpowder, and blood, but also of voices. And in these voices, the American victory found a unique timbre, that of constant presence even in absence. But as the Americans talked to each other, the heavens began to talk to them, because from above, a new dimension emerged, where war would be guided not by shouts, but by exact coordinates. And the next weapon? It would have no wheels. In the months following the collapse of the Third Reich, Allied interrogation rooms became spaces of revelation. There, far from the echo of orders and the smell of gunpowder, German generals, once towering figures on Wehrmacht maps, now spoke with quiet lucidity. For the first time, without the weight of propaganda or the chain of command, they confessed what they had refused to admit for years. The Americans had won the war not because they had better tanks, but because they knew how to make them work together. The phrase attributed to Marshal Wilhelm Keitel was recorded by a British officer with a mixture of surprise and respect. "We knew how to build better tanks. You knew how to make them fight together." The admission, coming from one of the highest names in the German High Command, was not just a military surrender. It was an intellectual surrender. This conclusion, however, did not come out of nowhere. During the war, dozens of American technical reports fell into the hands of German intelligence. Many described in detail the operation of the SCR-508 radios, the procedures for communication between tanks, the mission doctrine of the Allies. They were documents labeled archived and, ironically, ignored. Technical prejudice spoke louder. Germany, the birthplace of legendary engineers, simply refused to believe that such unrefined, mass-produced technology could be superior. A German engineer captured after the Battle of the Bulge summed up the mistake in a nutshell. "The problem is that we underestimate simplicity." And it was this simplicity that the Americans transformed into a system. Each button, each frequency, each field diagram was part of a functional whole. There was no room for individual genius. There was room for reliable repetition. War, for the United States, was first and foremost a matter of scalability. Radios didn't have to be the best. They just needed to work all the time anywhere. And they worked. Industrial discipline was converted into a tactical doctrine. The logic of the assembly lines has become the logic of the battlefield. And Germany, with its homemade tanks, its incompatible radios, and its inflexible doctrine, could not keep up. The German recognition, therefore, was not just a cold analysis. It was a painful process of self-criticism. In 1946, during the interrogations at Nuremberg, General Alfred Jodl was asked about the main factors in the defeat. He cited, among others, the astonishing ability of the Americans to maintain coordination under fire. In internal Wehrmacht reports seized by the Allies, there are direct mentions of the mind-boggling speed with which American armored units reorganized their attacks after casualties. The explanation, however, continued to be diverted. They attributed it to American operating culture or English influence. They rarely referred to the radio, as if it were humiliating to admit that a metal box the size of a backpack had won over the pride of the 88mm gun, but reality imposed itself. In NATO military exercises over the next few decades, German officers, now allies, began to study American command doctrine with technical fascination. Many recognized that the mistakes of the war had been structural, that it was not enough to have a good tank, if it operated as an island, that it was not enough to destroy the command tank, if the others took over in seconds, and that, above all, communication was the new form of command. Post-war exercises incorporated full use of transceivers, standardization of frequencies, operational redundancy. What Germany had despised in the 1940s was now basic doctrine in the 1950s. This recognition also reached the books. In the 1970s, German military historians revised the chronology of the defeat and included, for the first time, entire chapters on technological innovation in Allied communication systems. American radio began to be treated as a key piece, not as an accessory. The story finally was being fairly recounted, and more than that, with humility. Because what hurt the German officer corps most was not just losing the war, it was realizing that they lost to something they couldn't see, something they could not target with projectiles or destroy with tactics, a network of voices. Keitel's phrase eventually became a symbol of this moral surrender. By admitting that the Americans had turned the war into a living organism, coordinated by invisible signals, he did not just acknowledge defeat. He paid homage to what Germany refused to build, an army that spoke to itself, and that therefore he never marched alone. But there was still an unresolved lesson, a greater truth, one that transcended guns and cables. Because in the end, what the Americans created was not just a network of tanks, but a new way of thinking about war, and this idea, it was still expanding. When Sherman tanks crisscrossed France in 1944, guided by radio waves that connected them into a single tactical organism, not even their commanders imagined that they were inaugurating a new type of war. At the time, the SCR-508 was just a functional piece of equipment, a means to coordinate attacks, call for support, and avoid chaos. But in the invisible line that united one commander to another, one platoon to another, the seed of a strategic revolution was already pulsating. Decades later, military manuals would give a name to this phenomenon: network-centered warfare, and the American tanks of 1944 would be recognized as the first nodes in this lethal mesh. The legacy of the SCR-508 lies not only in the victories of World War II, but in the combat architecture of the 21st century. The logic was simple but transformative. An army that shares information in real time makes better, faster, and more lethal decisions. This philosophy was refined over the following decades, moving from the FM frequency to the digital protocol, from analog radio to satellite broadcasting. In the 1990s, during the Gulf War, the doctrine of networks showed its definitive power. Iraqi T-72 tanks, derived from the Soviet school, operated with superior firepower than the M1 Abrams in certain isolated respects, but they were tactically blinded. They didn't share real-time data, they didn't have integration with artillery or infantry, and they didn't know what the Americans knew, the exact position of each unit in the theater of operations. The difference was devastating. In a nighttime battle near Basra, Abrams tanks destroyed dozens of Iraqi armored vehicles before they were even detected. The American network, built with satellites, drones, GPS, and digital radios, allowed each commander to have an almost omniscient picture of the battle. The platform, once again, was won by the connection. The logic of knowing more, sooner, and sharing faster has become the new axis of modern warfare. And, surprisingly, this logic was already built into the SCR-508 of 1941. Contemporary doctrines recognize this legacy. The concept of network-centric warfare formulated by American officials in the late 20th century has direct roots in the principle tested in Kasserine Pass, that tanks that talk to each other beat tanks that just shoot. U.S. Army reports explicitly cite World War II as a turning point. One states, "The superiority of radio in the Shermans has revealed that coordination destroys isolation, and isolation kills." This view now dominates not only armor, but aviation, infantry, and even cybernetic systems. The war has become essentially a network versus network dispute, and the nodes of this network began with Motorola engineers, soldiers in the African desert, and voices that pierced the noise of machine guns. More than a technological milestone, American radio established a new operational ethic. He said, in clear frequency, "You are not alone." This idea, applied to logistics, command, and combat, has shaped the armies of the West for generations. In modern troop exercises, tanks simulate not only firing, but transmissions. Each unit is evaluated on its ability to communicate, coordinate, and adapt. Firepower, while still vital, is now subordinated to the ability to integrate. That's why modern tanks like the Leopard 2A7 or the Abrams SEPV3 come equipped with digital command systems that track, share, and synchronize actions in real time. The radio, which was previously an accessory fixed to a corner of the dashboard, is now the backbone of the combat system. The irony is that it all started with a practical, almost banal solution: stop the shouting on the battlefield. But by eliminating the noise, the Americans created a symphony. And this symphony echoed for decades. In 2003, during the early days of the invasion of Iraq, an American battalion covered 400 kilometers in 72 hours, with tanks, armor, and artillery moving as one body. The net once again won the ground, and the phrase of a captured Iraqi general repeated, with historical delay, what Keitel had already said 60 years earlier: "You fight as if you were one thought." At the center of this thought, there is not the shield, there is communication. Modern warfare, in the words of military theorists, is a Cognitive theater. The most decisive weapon is not the heaviest, but the most connected, and the Americans understood this before anyone else. The SCR-508 wasn't just a product of war, it was the manifesto of a new era. In every coded frequency, in every command transmitted, in every platoon saved by the voice on the other side, was the preview of the future. A future where winning meant, first and foremost, listening. But the legacy of radio doesn't end with cables or antennas. He transformed doctrine, industry, and most importantly, mentality. And it is this transformation that explains how a technically inferior tank beat armored giants. Because in the end, Sherman was never alone. He was part of something bigger, a network, a doctrine, an idea. And this idea still echoes. Because there is a place where this network remains active, invisible, and lethal. And that is where we are going. When the engines of the last panzers fell silent, and the roads of Germany were overrun by Allied columns moving with mathematical precision, the Reich's doctrine of technical superiority collapsed definitively. The Panther tank, the pride of German engineering, was defeated not by a more armored or more powerful rival, but by an invisible, silent, persistent enemy, the network. The United States did not win the war with steel alone. They won with organization, mass production, and above all, communication. The SCR-508 radio, housed discreetly inside each Sherman, became the tactical brain of a force that thought along, decided along, and reacted in real time. While Germany relied on leading vehicles and unilateral orders, the Americans built an army of thousands of synchronized brains. The centralized German logic collapsed in the face of a decentralized adversary, where every soldier, every platoon, every commander could be heard and respond. This was the ultimate ideological defeat, not just of a nation, but of a mentality. The great lesson that this story delivers is brutal in its clarity. Logistics is not the backstage of war. It is war itself. The production exceeds the project. Flow beats steel. The network annuls the myth of isolated force. In an era that still celebrates tanks, fighter jets, and bombs, this story reminds us that the most powerful tool remains the one that connects, not the one that destroys. As General Heinz Guderian admitted, decades after the end, we lost to an enemy who understood something we have forgotten. War is not made of tanks, but of systems, and theirs worked. If you value serious research and reconstruction of the hidden facts of history, please support this channel with a like and subscribe. This allows us to continue revealing what was left between the pages and the noises of war. Comment below, what was the most shocking data you discovered in this video? And ring the bell so you don't miss the next devastating historical fact we're going to reveal. Don't go away yet. Listen to the next true story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.